Hello and welcome back to CSC's live chat. I'm Sukanya Nair and I have with me Akshit Sangomla from downpour. Hi Akshit, thank you so much for joining.
Hi. Hi,
So
Sukanya.
last hi. So last week, Delhi and the National Capital Region experienced unprecedented rainfall. And last Friday, Delhi recorded 228 millimeter of rain, which is the second highest the city has seen in a day in June since 1901. We saw many roads flooded, and we even saw the viral video of Terminal 1 collapsing. So, Akshat, my first question to you is what really happened and what are the scientists saying?
Yes. So basically, as you have mentioned, there was a lot of rainfall on in the on the intervening night between June 27 and June 28. Basically, Safdarjung Observatory recorded that 228 mm of rainfall that you just mentioned. There were other observatories as well. Lodi Road recorded around 192 mm. The Northern Ridge Observatory near Delhi University recorded around 150 mm. So there was a lot of rainfall that happened on that day. And very interestingly, much of that rainfall. So these figures are for 24 hours between 8:30 a.m. on June 27 and 8:30 a.m. on June 28. But most of this rainfall actually occurred in the early morning hours of June 28, which was basically between 3 a.m. and 6 a.m. And the maximum intensity of the rainfall was between 5 a.m. and 6 a.m. That means like a lot of rainfall basically happened in a very, very small time, a small period of time. And that is why we saw all this flooding, flash flooding, kind of flash flooding that had happened. We saw the Terminal 1 roof collapsing. One person died in that. Overall, I think around 11 people were killed because of different flood-related incidents. Four of them basically were trapped in underpasses where flood waters had gushed in and they could not, escape from there. So all this happened because
Your voice is slightly breaking.
of the intensity of the rainfall. One
Um,
is that, and also the timing, because in a very short period of time.
Akshit?
Yeah, I
Just,
can.
just give me a second. I'm not able to hear you.
Okay.
You can carry on. I think you're audible now.
Okay. Am I audible to you?
Yes, yes.
Yeah, sure. So yeah, what I was saying was, a lot of rainfall basically happened within a very short period of time, and that is what basically caused the flooding. That is what happened on June 28th. Such kind of rainfall was last seen in 1936, when 235 mm rainfall fell in a single day on June 24th in that year. And so, yeah, so in the last 88 years, it's the first time that we are seeing this kind of rainfall. We have seen this kind of rainfall in Delhi.
So is it happening across the country? And can you tell us if there is any linkage of this with climate change?
Basically, why this has happened is basically because of a lot of systems, a lot of weather systems coming together over Delhi. Some local systems, some systems that were from outside. The primary reason for this was an active and strong onset of monsoon, of the southwest monsoon over Delhi. This basically happened at the same time. Basically, there are two branches of the monsoon, of the southwest monsoon. There is the Bay of Bengal branch and there is the Arabian Sea branch. And both these branches basically advanced over Delhi on this thing within a very small time frame. Basically, the Bay of Bengal branch was stalled for a very long period of time, from May 31st to around June 19th. It was stalled in Northeast India, and then it started moving around June 20. And even till June 25, it was very sluggish. It did not move a lot. And the Arabian Sea branch was also stalled in Maharashtra for quite some time, for a week, for a couple of weeks or so. And both these branches basically moved together over Delhi. And it was a very strong onset that happened over Delhi. That is the primary reason for why there was so much rainfall. The second reason is the presence of a western disturbance over India at the time, and also an associated cyclonic circulation. A cyclonic circulation is basically a swirl of winds in the middle layers of the atmosphere, which basically causes rainfall. Most of the rainfall during winters happens due to these cyclonic circulations, which are induced by western disturbances. And western disturbances are extratropical storms, which are carried by the subtropical jet stream from the Mediterranean Sea over Iran, Afghanistan, Pakistan, and India. They basically mostly cause rainfall during the winters for us, and also during the spring season. And they also cause thunderstorms during the spring season. So this was the other reason. The third reason was a lot of moisture that came in from both the Arabian Sea and the Bay of Bengal. There were very strong winds from both the Arabian Sea and the Bay of Bengal that were bringing in moisture. Moisture is important for causing these thunderstorms and rainfall. And there was also a low pressure area over Bay of Bengal, which was also aiding in the moisture incursion. The last factor is basically a localized factor, which was basically an anticyclone over towards the northeast of Delhi. So during an anticyclone, which is basically a high pressure area in the atmosphere, what happens is the air towards the upper layers basically diverges, moves apart. And this basically causes the lower layers of the atmosphere to get winds in, and they collect moisture. And that also aided in there being a lot of moisture in that area for in that particular period. And locally, what happened was there was a mesoscale convective system, what the IMD calls a mesoscale convective system, which is basically a series of thunderstorms, a combination of thunderstorms happening at the same time. And this basically can go on till 100 kilometers. Like, for instance, there can be a 100-kilometer cloud cover over a single region due to these mesoscale systems. And that IMD says is the primary is what caused such intense rainfall to fall in such short period of time.
So one question that is in everyone's mind is, why is the IMD going haywire with its prediction?
Yeah, so IMD IMD has not been able to predict these systems very well. First of all, these are very small scale systems, even though there are so many large scale factors, as in the moisture coming in from the Bay of Bengal, the Arabian Sea, the monsoon system, the western disturbance. These are all large scale factors. But at the end, the actual rainfall has to happen from a series of thunderstorms, which are very difficult to predict even now for IMD or for many other weather agencies around the world, because that would take weather models to be extremely precise, very accurate, and at a much smaller scale. As in the refine, they have to be much finer. As in their scale has to be able to predict these very small systems which are forming on a very smaller scale. Because predicting the monsoon is also very difficult for us. Predicting the western disturbance, which are two independent factors, are also very difficult. And then them coming together and forming these mesoscale systems, prediction of that for IMD or for any other weather agency is extremely difficult. One factor is that. The other factor is also that IMD doesn't yet, or in general, science doesn't understand western disturbances completely. And we are not very good at tracking them. We are not very good at knowing what kind of strength they'll have, what kind of, if they'll be weak, they'll be strong, if they'll be interacting with other systems. We don't exactly know how those dynamics are working in the atmosphere. And that is why predicting these, extreme weather events, extreme rainfall events is quite difficult still. But as weather models improve, as climate models improve, I think we'll be getting there, where they become more, their resolution improves, and smaller scale events such as these are also, we are able to predict them. The other important factor is also climate change, because both western disturbances and the winds and moisture coming in from the Arabian Sea have an imprint of climate change in them. Because Arabian Sea has warmed a lot in the past 2 decades. In fact, 1.2 to 1.4 degrees Celsius warming has been seen in the Arabian Sea in the past 2 decades. And western disturbances have been coming in much more towards summer. They usually come in the winters. They bring most of our winter rainfall, most of our winter snowfall. But this year, for the past few years, they have been coming in more towards the summer, and this basically increases their chances of interacting with the monsoon system, and that is why basically it also becomes very difficult to predict them.
So my final question to you is, what can we safely predict for the coming days in terms of monsoon, especially with respect to Delhi and the NCR region, and what needs to be done to make better forecast of such wind?
Yeah, so in the coming days, Delhi, I think, is receiving rainfall today and tomorrow. Some rainfall is predicted for Delhi for today and tomorrow, and after that, not much rainfall for a few days. But for July, in general, IMD has predicted above normal rainfall for most of India, including Northwest India, which includes Delhi. But in the next few days, definitely there's going to be heavy rainfall in the Himalayas. That's what IMD predicts. Most of the Himalayan states, especially Uttarakhand and northeastern states of Arunachal Pradesh and Meghalaya, are under severe rainfall alert for the next few days, and I think that is going to remain unless and until monsoon, goes on a break, and then there's only rainfall in the Himalayas and the northeast, and then the rest of the country will not get a lot of rainfall. Until that happens, I think this rainfall will continue. July will get a lot of rainfall, including in Delhi.
Okay. Thank you so much, Akshit, for joining us. Thank you so much for everybody who's watching us right now. We'll be back soon with the next episode of Live Chat. Bye-bye.
Thank you.
Bye-bye.